Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Motion. Now we will understand two important concepts, distance traveled and displacement. Suppose imagine you are starting from your house, that is this point, that is A, and first you are walking southern direction. So you know that this is west, this is east, this is north and this is south, right? So from here you are moving or you are walking 3 kilometers towards the south direction and you are reaching a point B. After reaching point B, then you are turning to east and walking another 5 kilometers and you are reaching a point C. Okay, so here maybe this is your destination you wanted to go. Now in this case, the actual path you traveled is the distance traveled. Okay, the actual path is the distance traveled, that is equal to AB plus BC. What is AB? 3 kilometer plus 5 kilometer, total you walked 8 kilometers. Okay, the actual length of the path moved by a body in a given interval of time is called the distance traveled by it. So in this case, the distance traveled is a total distance covered by this person or you. Okay, another case, suppose this is your house, okay, and here is your school. So you have the, you can go, you are going to your friend's house, calling your friend. From there you are going to a shop where you have to buy some stationery. From there you came here, then you are meeting another friend of yours and then you are all going and there is a ground near your school, you are playing there and finally you are reaching to your class. So the distance traveled is too long, right? So the actual path which all ways you walked or you traveled, that is called your distance traveled. But if you see, the shortest distance between the initial point and the final destination is measured. For example, here though you came 3 kilometers southwards and then you walked 5 kilometers east, but the actual distance is this AC, right? The same way here also, from your house to school, if there was a straight road and you did not take any other deviation, then you would have traveled only this much. So this shortest distance between the initial point and final point of a moving body, that is called a displacement. So in this case, what is the displacement in this? It is the AC. So how can you find AC? AC will be the square root of AB square plus BC square. So in order to get the square root, I am changing this to 4. So it will become 3 and 4, 7 kilometer total. So here what can I substitute? AB square is 3 square plus BC square is 4 square. So 9 plus 4 square is 60, square root of 25, so I will get 5 kilometers. So the shortest distance between A and C, that is your starting point and your reaching point, that is only 5 kilometers. So that is a displacement, but actually you travel 7 kilometers, 2 kilometers extra. The same way here also, this was the actual path taken by you, that is the distance travel, but the shortest distance you could have covered is displacement. So the actual length of the path travelled by a body, moving body in a given interval of time is called a distance travel. At the same time, the shortest distance between the initial point and the final point of a moving body is called the displacement. Now, if you talk about distance travel is always positive because a body starts moving, that means it has attained or it has travelled some distance. It can never be zero. Never it is zero or negative. It's always positive because even if from here I stepped it, one step itself I have moved a distance, right? So it is never zero or negative. But in case of displacement, if suppose you are going from this A to B and then you go from B to C, suppose you went to buy something from the shop, but after that you are coming back and you reach back the position, original position, maybe this is your house. So in this case, you are coming back to your house means what? Your starting point and your ending point now becomes the same, and the starting point and ending point, the difference is 0. So displacement can be 0. Of course, if not coming back, then it is positive. and also it can be negative at certain times. For example, if a ball is thrown vertically up, then its movement is negative. But if the ball goes up, that is negative, then falls down after reaching a point, that is positive, but it comes back to my hand again, then the displacement becomes 0. So, but what is the distance traveled? Suppose from here I am throwing up a stone, it is traveling h meters, and after reaching here it comes back, then that is another h. So the total distance traveled is h plus h 2h, but the displacement is 0 because it has reached the same place from where it was thrown up. Okay, so the displacement can be 0, positive or negative, whereas distance traveled is only positive. It can never be 0 or negative. Another thing, what is the SI unit? SI unit is measured in meter for distance, even displacement it is meter. And how do you represent it? Distance traveled is represented as s or small s. Okay, so these are displacement or distance traveled, it is by s or a small s. So hope you understood this. Let's see two numericals based on distance covered and displacement. So the first question is, a body is moving along a circular path of radius r, distance and displacement after half revolution. So suppose a body is starting from here, it is covering a circular path and coming here. Okay, so they are asking the distance traveled. The distance traveled after half revolution. Half revolution means from here till it reaches here. This is half revolution. So for a circular path, if he is completing, it should be equal to the circumference, right? So here distance, he is not covering the entire circumference, but he is covering only the half the circumference. So distance is half into, what is the circumference of a circle? 2 pi r. So we can cancel out this 2. So the distance traveled by this body is pi r. Okay. Now coming to displacement. Displacement means what? Suppose this is the starting point and here is the final point. The shortest distance. So this is the distance traveled, but displacement is this distance. This distance means what? Diameter, right? So that is 2r. So displacement is 2r. That is double the radius, or we can say diameter. Now the next question, an athlete completes one round of a circular track of diameter 200 meter. So this is the circular track. Suppose he is running and he is starting from here. The total distance covered by him is its diameter is 200 meter. Okay, but he covers it in 40 seconds. So total time taken by him is 40 seconds. What will be the distance covered and displacement at the end of 2 minutes 20 seconds? So first let us see 200 meter when this is the diameter, but what is the circumference of this track, so that we will find out the distance traveled in 40 seconds, because one round 40 seconds he took. So the circumference is 2 pi r, right? So 2 pi r is equal to 2 into 22 by 7 into r is the half of it, that is 100. So we can write 4400 upon 7 is the distance traveled in 40 seconds. But now we have to find out what is the distance traveled in 2 minutes 20 seconds. 2 minutes means what? 1 minute is 60 seconds. So 60 plus 60, 120 seconds plus another 20 seconds. So total 140 seconds he has traveled. So 40 seconds he is traveling this much distance. So 140 seconds, how much he is traveling? So we can cross multiply. So the x, or the distance traveled, is in 140 seconds is equal to, that is cross multiplying 4400 divided by 7 by 40 into 140. So how will you find out that? 4400 by 7 into 1 by 40 into 140. Okay, so this we can 110. So 110 into, so this will become 2. So it will become 2200 meters. So you know that one round he takes 4400 by 7 meters he has to travel. So 2200 meters means how many how many rounds it is? that is 2200 into 7 upon 4400, right? So you can say that this is 2. So 7 by 2, he has run 3.5 rounds, not meter. 3.5 rounds he had to run to cover this much distance. So one distance, first time he is completing first round, again he is coming back, the displacement is 0. Once again he is completing second round, again 0, because he is coming back to his original position. Third round also he completes 0. Now another half round he is completing, so he is reaching this point B. So then the displacement will be the shortest distance, which is equal to the diameter of the field, that is 200 meters. Motion along a straight line can be represented in two ways, either in a mathematical expression or in a graphical form. So let's see one more example of distance traveled by and displacement. Suppose you are starting from your house. Okay, you are traveling 30 km to reach your relative's house, which is located at a city B. From there, you are traveling another 20 km to meet one of your friends who is staying at a C. Then you had to travel another 50 km to reach your new institution or college you are joining. Okay, so here we can see that the total distance traveled by you is 30 km plus 20 km plus 50 km, that is AB plus BC plus CD. So total how much you travel? 100 kilometers you covered. Okay, now after, so maybe you went for some admission or you went to some place to attend a wedding or something. Then you are coming back and again meeting your friend, because you had promised that you would stay there for one day. So you are coming back here. Okay, so before that, in this case, first case, displacement is also 100 km, because you reached from A to D. It's a straight line, so distance covered and displacement are same when it is in a straight line. Now you are traveling back. So from D, after reaching D, you completed your task and you are coming back to C and you are halting there. So now what is the distance covered? So in the second case, distance covered is 30 plus 20 plus 50, already traveled, but now you travel back another 50. So it became 150 kilometers. But what is your displacement in this case? Here the initial point was A, but your now final point is C. So the distance between initial and final point is 30 plus 20, 50 kilometers only. So though you traveled 150 kilometers total, now your displacement is only 50 kilometers. So imagine again after you are traveling from here till here to B. So in this case, what is the distance travel? Distance will be 30 plus 20 plus 50. Then you travel back 50. Now you travel back another 20. So your distance will be 50 plus 50, 150 plus 20, 170 kilometers you totally travel. But now your displacement has decreased again, because now your distance from the initial point and final point is only 30 kilometers. Okay, so this is how it differs. Let's now talk about uniform motion and non-uniform motion. So uniform motion means if a moving body is traveling at equal distances in equal intervals of time. For example, imagine a car moving at a constant speed. So first 10 minutes it covered a particular distance, maybe at 10 minutes maybe 30 kilometers it covered. Another 10 minutes again another 30 kilometers. Another 10 minutes again another 30 kilometers. So every time it is traveling at the same speed or equal distance is covered at an equal interval of time. So then we call it as it is in a uniform motion. But if the object is covering unequal distances in equal interval of time. So first 10 minutes it covered 30 kilometers. But another next 10, in time interval is the same. Another 10 minutes it is covering only 20 kilometers, maybe due to traffic. Then another 10 minutes the car is moving faster, maybe 45 kilometers, because the driver wanted to cover up the what he lost in the traffic. But it is a highway where, or the expressway where he can travel at a very high speed. Okay, so this is the way we are telling about uniform motion and non-uniform motion. Equal distance is covered in equal interval of time, it is uniform motion. Unequal distance in equal interval of time, that is non-uniform motion. Examples of uniform motion are hands of a watch. You know that it is taking the same time, every time 60 seconds it takes to complete 1 hour, right? The same way earth in its axis, 24 hours it takes to complete 1 rotation, or earth around the sun. So it is moving with a constant motion, that is uniform motion. Whereas the vehicles, you know that I was talking about a car which is already in motion, but think of a situation where if the car is in a very heavy traffic. So you know that when we are starting from home, that may be a small road, we have to go little slow, then we are reaching the highway, we are taking a faster speed, and after some time there comes a signal where we have to slow down, then we take again. So the time interval changes, means it is speed is also changing. And also freely falling body under the force of gravity, it will be increasing its speed. So actually it is covering more distance, or a different distance in different equal intervals of time. Then if a car is moving at a speed, but when all of a sudden brake is applied, it will slow down. Or oscillating pendulum, you know, first it is oscillating, but then it slowly decreases its speed and comes to a still position. So here all what is happening, unequal distance is covered in equal intervals of time. If you see the graph of this, if you plot time in the x-axis, distance in the y-axis, then here the graph obtained will be a straight line. Whereas in this case, if you plot time here and the distance here, then the graph will be a curved shape. So this uniform motion gives a straight graph, non-uniform motion, the graph is a curved line. Hope you find my videos useful. If so, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.